Hello learners. So in this module 1 of embedded system design using 8051 microcontroller series of video, I am going to give you the introduction about what is embedded system and some of the examples for embedded systems. Right? Now what is embedded system? What is an embedded system? Embedded system is a special purpose computer system, usually completely inside the device it controls. That means the device may be the television, the smart TV in your home, and a small computer system sitting inside your TV controls your TV functions, television functions. Right? So there is a small subsystem, small computer system sitting in your smart TV to control various functions of the TV through the remote. Right? In this TV, in this example, your television is a main system and the small subsystem embedded into the main system is a embedded system. Right? So this way you can define what is embedded system. The another way you can say the embedded system is an electronic device that incorporate computer in their implementation. That means, as I told you, a small system embedded into the main system. In that example, a small computer system embedded in your television to control various functions of your TV is an embedded system. That embedded system is nothing but an electronic device that incorporates a small microprocessor or microcontroller. Right? So embedded system is a combination of hardware and software to perform a dedicated task. That means the embedded system is a circuit, hardware, which is embedded into the main system to control the function of the main system or to assist the function of the main system. But that embedded system is in the form of hardware and software. That means the circuit having a microprocessor or microcontroller and memory, and the software, that means the task to be done by the embedded system is written in the form of software and stored into the memory of the circuit. Memory, right? That software will do the task by means of the hardware. That is the embedded system. Okay, so embedded system is a hardware. It has got a chip, memory, everything, and the task to be done by the embedded system is stored in the form of software into it. That is the idea. That's what we say. The embedded system is the combination of hardware and software to perform only one task repeatedly. Usually embedded systems are designed to perform a task repeatedly whenever the system is switched on. After powered up, the system will do the task. Right? That is the embedded system. Now, most often the embedded systems are designed to give intelligence to the normal system or to make the small normal system into a smart system. For example, if you want to give some intelligence, right, some intelligence to the system, For example, you have a door, normal door. When you push up, you can enter, and it will automatically close it. Let it be. Now, if you want your door to be automatically open, that is intelligent door, right? So see, these embedded systems are usually designed to give intelligence to the system, to make the system smart one. The another purpose is to automation. So wherever you need a small scale automation required, there the embedded system is used, right? So in this door example, you can have some sensors to sense the presence of the person nearby, and whenever the signal comes from the sensor, so your hardware, your embedded system will open the door, and it will close the door. Whenever nobody is there, it will close the door, something like that. A small intelligent door. Similarly, many systems, many normal system, you can make it as a smart one, right? Say for example, your AC, whenever a person entered into the room, your AC may be automatically switch on, right? Switched on. And also, if many persons are entering into the room, that AC can adjust the temperature. It can reduce the temperature based on the number of persons inside the room, and if somebody is going out, it can increase the temperature. So all these intelligence to the AC air conditioner, you can implement by means of a hardware and software. You can embed the hardware with the software to do this particular task into your AC. Then your AC will become a smart AC. That is the idea, right? Similarly, you can implement your idea, any of your innovative idea you can implement if you know to design the embedded system, and if you are familiar with the embedded hardware and software, right? So embedded system is a dedicated device used to control, monitor or assist the main system. That is the idea. Now let us see some examples of the embedded system. So many years back, the embedded systems have been in the in a commercial market. See, this is one of the commercial product, Wendo VMAX 720 vending machine. It's an old machine. So this is the main system. Okay, so the system will deliver the cool drinks automatically when you keep the vessel. Okay, now this particular system is an automated intelligence system. The automation or intelligence is done by the embedded system sitting inside this main system. That small embedded system sitting inside this vending machine is designed with the 8-bit Motorola 68HC11 microprocessor. Right? I told you embedded systems are designed. Embedded system is nothing but the combination of hardware and software. Right? Embedded system is a design of combination of hardware and software to do a particular task, right? So here, this particular system, the hardware used to design this system is 8-bit Motorola 68HC11 microprocessor. Similarly, another product from Sonicare Plus is a toothbrush designed using a 8-bit Gilac Z8 microprocessor. The hardware is a 8-bit Gilac microprocessor, right? Of course, what this brush should do, that is the task, is done. Task is written in the form of software and stored into the system. And the another example of a dishwasher designed using a 8-bit Motorola 68 HC5 microprocessor, and NASA's Mars rover, it is designed with 8-bit Intel 8085 microprocessor, right? So in our embedded hardware, so some of the sample embedded systems are shown in this picture. So thermostat, Mars rover, and MP3 player, cool drinks vending machine, and memory pad, cell phone, a robo, even an automobile car. So these are some of the systems in which subsystem is embedded, right? So all these systems have got embedded in the system into it, so they are called embedded system. And apart from that, there are so many in different field. Embedded systems have got different applications in aerospace, navigation systems, automatic landing systems, flight altitude control, engine control, space exploration, so many. So more than 100 sensor-oriented embedded systems are there in aeroplane, and an automotive applications in a car. We have fuel injection control, passenger environmental controls, and anti-lock braking systems, airbag control, GPS mapping. So these are some of the embedded systems. For these applications, systems are embedded into a car, right? So airbag control means see there will be a sensor, acceleration sensor in a car. So when there is a sudden stop, when car is suddenly stopped, and it's sensed by the acceleration sensor, and airbag will be opened automatically. Like that, so many applications are there in automatic applications that is done by the embedded system. And even children's toy, American small toys, Game Boy, interactive Boo. So these are all some of the embedded systems developed for the kids. And even satellite network routers, switches, hubs, all have got in embedded systems. And the computer peripherals were printer, scanner, keyboard, display, modem card, hard disk, CD drive, all are got embedded system. See, for example, take a printer. So printer has got its own hardware, so microprocessor or microcontroller and a memory, and software is written and stored in a system. So the task of the printer is whatever the data received from the computer, it has to print. Okay, that particular task will be done by the printer. Okay, because of the hardware and the software embedded into it. That is why a printer is an embedded system. And our keyboard has got its own small microcontroller, 8048, something like that. And the task of the keyboard, that microcontroller is, so whatever the key is pressed on a keyboard, it has to sense the key, and accordingly it has to give the scan code to the system computer. So every embedded system have got its own task. So in the home applications, so many embedded systems are there. Dishwasher, microwave oven is an embedded system, VCR, television, stereos, fire safety alarm, lawn sprinkler control, that is being used in a field, lawn sprinkler to for water spray, and thermostat for the temperature control, and even smart cameras, clock radios, answering machine are all embedded systems only. In industrial applications, so many applications are there. Here only the elevator control and surveillance systems, robots are some of the examples given here. And even instrumentation, data collection, that is data acquisition from the sensors, data acquisition systems are small embedded systems. And oscilloscope means here the oscilloscope mean digital storage oscilloscope, right? Intelligent oscilloscope. So whenever a system is intelligent, there will be a small hardware, a piece of hardware and software in it that is embedded into it. That is called embedded system. And signal generators, intelligent signal generators, signal analyzers, spectrum analyzers, and so on. Okay. So these are some of the examples for embedded system. So let me recall. The embedded system is nothing but software, hardware plus software, right? So embedded system can be said as a combination of hardware and software to perform a task repeatedly, right? Whenever the system is powered up. So whenever the system is powered up, a single task or some tasks will be done by the system repeatedly. The task is written in the form of program stored in hardware, right? So basically we need a hardware and software to implement the embedded system. So embedded system is a group, it's a combination of hardware and software. Hardware means it may be here it refers to the hardware refers to the processor, memory and peripherals, right? Processor, memory and peripherals. Processor may be a microprocessor or a microcontroller or digital signal processor, or even it may be a empty processor like VLSI core, FPGA based CPLD, right? FPGA means field programmable gate array, and CPLD is a complex programmable logic device based system, and application specific integrated circuit. These are all basically using VLSI technology. These ICs can be done, right? Even in an FPGA, any microprocessor or any microcontroller core can be implemented in a FPGA, right? So that is a VLSI technology. And system on chip is the latest technology by which embedded systems are being implemented, right? And so these are here the processor refers to the microprocessor or microcontroller or digital signal processor or VLSI core. Any one of these form, processor may be in any one of these form, and memory refers to the ROM and RAM. There are different kind of memories, different variety of memories, right? So depends on our requirement. There must be any memory. Okay. So memory is must for the embedded system because we have to store the software into the memory. Okay. And peripherals are the peripherals through which only the processor. See, for example, the peripherals refers to the serial ports, parallel ports through which the data is coming into the processor from the external environment, or sending the data out through the port to the external environment, right? So there are two kind of ports, serial ports and parallel ports. Serial port, there are different kind of serial ports, RS-232, RS-422, RS-4 here are SPI, SCI, CAN, controlled area network. CAN is the kind of bus technology being used in automobile applications most often. So in embedded systems in the automobile, many embedded systems in a car, in automobile system, are connected through this kind of CAN buses, sensors and actuators. And I2C is another serial port or bus, master slave based technology, and universal synchronous bus USB. So these are some kind of serial ports. Any one of the serial port the processor or microcontroller can use, right? And ADC, DAC, basically these two peripherals very much required for the processor to control the analog data, to handle the analog data from the environment and to the environment. And BWM is a pulse width modulated output. This will be required to control the speed of the motor and so on, many applications. And timer is the important peripheral required for the embedded system, because in many applications we need to do the activity with respect to times. Okay. And interrupt mechanisms, that is one of the important mechanism in a in a system. And displays, right? LED, LCD, these kind of displays are required for the embedded system. So most often all these peripherals may be required, depends on the application of the embedded system, right? So you have to understand very clearly that embedded system is a combination of hardware and software. Here hardware refers to the three important different kind of circuitry, different kind of hardware. That is central processing unit, that is nothing but a processor. It may be a microprocessor or microcontroller or any other kind of processor. And memory, the second important hardware required is memory. It may be a ROM, RAM, and any different technology based memory. And peripherals, third important hardware. So it may be a serial port, parallel port, signal conditioning circuitry, ADC, DAC, timer, counter, everything. So these three important hardware is required for an embedded system: processor, memory, and peripherals. And software is a program, right? There are so many IDEs are available in the market. So integrated development environment through which the program can be developed and put into the memory, right? So that is the embedded design methodology. Now let us discuss in detail about the processor, right? Because that is the important part of the hardware. So we know embedded system is the combination of hardware and software. In a hardware we need three kind of hardware: program, processor, memory, and peripherals. So processor is the brain. Processor is the brain part of the embedded system, right? Processor is the brain part of the hardware, right? So let us discuss the microprocessor or a microcontroller. Both kind of your embedded system may employ either a microprocessor or microcontroller. But let us understand what is microprocessor. So basically there is a architecture methodology, computer architecture. I mean the mostly microprocessor follows the von Neumann method of architecture. What is it? Von Neumann machine. See, that means CPU, central processing unit. The circuit involved in the central processing unit, entire central processing unit, fabricated in a single chip using a VLSI technology, is called microprocessor. Okay, so microprocessor is nothing but a central processing unit. Whatever the circuitry required for the central processing unit, fabricated on a single chip using a VLSI technology or advanced technology, is called a microprocessor, right? So it will process the data. That's why it's called as a processor. Process means it has got a, for processing, it has got a main circuitry called ALU, right? Arithmetic Logic Unit. So this is a very complex logic circuit, right, can perform arithmetic and logical operation on the received data. Okay, so look at the ALU symbol. It has got the one side, it has got 2 input and 1 output. Okay, it can receive 2 input and give output. So the 2 input data it may be a multi-bit data. For example, it may be 8-bit data, it may be 4-bit or 8-bit or 16-bit data or 32-bit data. So depends on how many number of bit data it can receive and do the process, arithmetic and logical process, perform the arithmetic and logical processing, and it can give output, right? So depends on that, the ALU capability of the ALU varies, right? So depends on the capacity of the ALU only the processor capacity lies. That is, if a ALU is a 8-bit ALU, that processor is called 8-bit processor. Otherwise, 8-bit processor always have a 8-bit ALU circuitry, and if a 16-bit processor means a 16-bit ALU, and 32-bit processor it will have 32-bit ALU. That means, see, for example, let it be a 8-bit ALU. This ALU at a time can receive 2 8-bit of data and perform any arithmetic and logical operation on the data, and it can give output, right? So that is the ALU circuitry. Fine. So this is the core circuitry, brain part of the CPU, ALU, right? So we know that any microprocessor should have a ALU. Try to understand, in any microprocessor is nothing but the CPU fabricated on a single chip using VLSI technology, and this processor will have many circuits. The main part of the circuit, the brain part of the circuit, is a ALU, right? So any microprocessor should have ALU primarily into it. Apart from that, it should have a control circuitry, right? What is meant by control? So for example, it has got lot of functions, control circuitry. So one of the important function is it see, the ALU, whenever it receives data and receives command, it will perform the command and give the output. For example, if you want to add 2 numbers, it will receive data as a 2, it will receive the 2 numbers as a data, and it will receive command. Command is what kind of operation to be performed, because ALU can do any arithmetic or logical operation. Suppose if you want to add the data, so command is add. So whenever this data, command and all supplied to the ALU using a control circuitry, right? So control circuitry has got lot of functions. It's a complex circuit, and one more important thing is clock. Any CPU, it should receive a clock input, right? So clock, only the frequency of the clock decides the speed of the operation of the central processing unit. Say, we learnt that ALU can perform any arithmetic and logical operation. How fast it can perform, it depends on the clock frequency of the central processing unit. Okay, this circuitry, actually it has got a very complex sequential logic circuit inside the ALU and control circuitry. They are driven by the clock, right? So the clock frequency, there is a range, highest frequency, what may be the highest speed in which the processor can work, and low frequency also, right? So that is decided by the clock. So clock is one of the backbone for operation of this circuit. And registers, see, registers are the small another circuitry. Actually register means, here registers refers to the group of register, right? So register is nothing but a group of flip-flops, maybe a D flip-flop. So let us consider a 8-bit register that is formed using a 8D flip-flop, 8D latch or 8D flip-flop, right, connected together to form the 8-bit register. It can store 8-bit of data, right? It can store the data temporarily, 8-bit of data, if it is 8-bit registers, right? So when I talk about a 8-bit microprocessor, it will have a 8-bit ALU and group of 8-bit registers, right? So how many registers will be there? It depends on the it depends on the architectural designer. So mostly the number of register will be limited, right? So minimum number of registers will be there. The purpose of the register is to store the data temporarily, right? See, for suppose here, whenever if you want to perform addition operation between two data, suppose if you want to add 4 plus 5, so that addition is going to be done by the ALU, performed by a ALU, right? So ALU, whenever ALU receives data and command, it will perform the addition operation, right? Add command. But where from the data will be supplied to the ALU? Most often from registers, right? So if I want to add 4 plus 5, 4 will be stored in one register and 5 may be stored in another register. So from the register, data is given to the ALU. That is the idea. So data 4 and 5 temporarily stored in a registers, and it is given to the ALU during the operation, during the performance of particular operation. Okay. So any microprocessor will have some set of registers to store the data temporarily before the data is given to the ALU, right? And so these are some of the important blocks we have seen in inside the microprocessor chip or microprocessor unit. But mostly microprocessor will not have a memory on chip. It will not have a memory inside the microprocessor chip, right? So in von Neumann architecture, the memory is a separate entity. It's another chip. Memory is an external chip to the chip or external circuitry where you can store large amount of data, right? See, here the capacity of the memory mostly depends on the capacity of the addressing capacity of the central processing unit. That means the number of locations in this external memory, here the memory is nothing but a group of registers. You can view this memory as a large group of registers, right, to store the data as well as program. So in von Neumann machine architecture, both program and data will be stored in a single space memory, right? So in a memory, program as well as data is to store the program and data. We have a large number of registers, group of registers in the chip. That is memory. How many number of registers or how many number of locations will be there in a memory depends on the addressing capacity of the processor. What does it mean? Meaning is, suppose if a processor is a 8-bit processor, that means it will have a 8-bit ALU and a group of 8-bit registers inside. All these blocks inside the ALU, registers, clock, everything are connected together by a buses, internal bus, and this memory, this CPU or this microprocessor and the external memory is also connected through the bus, right? So bus is a group of wires. Bus can be viewed as a group of wires. There are basically three type of buses to connect the processor and the external memory. They are address bus, data bus, and control bus, right? Here these three buses are shown in different colors to make you to understand, right? Address bus, data bus, and control bus. So what is address bus? Means carrying the address from the microprocessor to the external memory, right? Address bus carries the address from the central processing unit to the memory. And what is the direction of the data flow? Always the direction of data flow in the address bus is from CPU to memory. Why? Because memory is simply a storing device where commands as well as data, group of commands as well as data are stored, right? So whenever the command or data required by the processor have to fetch the address, fetch the command or data by sending the address to the memory, right? At any time we no need to send the address by memory to the CPU. Always address will be sent from the CPU to memory. That's why it is called unidirectional bus. The direction of data flow is always from CPU to memory, unidirectional bus. Okay. Now the question is, how many wires are there in an address bus, or the width of the address bus? That depends on the memory capacity, number of locations in the external memory. That's what I said. The number of location in the external memory is dependent on the addressing capacity of the processor. The relation is, suppose if there are n number of address lines, 2 to the power n memory locations will be there in external memory. That means if there are 16 lines in the address bus, 16 wires in the address bus, 2 to the power 16, 65,536 locations will be there in this external memory, right? 65,536 location. Okay. For example, in each location, let we can store 8-bit data or 1 byte of data. Then out of the 65,536 location, we can store 64 kilobyte of data. 65,536 bytes is nothing but 64 kilobyte divided by 1024. So that is the addressing capacity. So the number of locations in the external memory depends on the number of address lines in the processor. Okay. So this will vary from processor to processor. If a processor have 16 address lines, it can address up to 64 kilobyte memory. 2 to the power 16 is 64 kilobyte. If the processor is having 32-bit address line, then 2 to the power 32 number of memory locations it can address. Okay. So the size of the memory depends on the number of address lines in the processor. Next, there is another bus called data bus. So this data bus means is again a group of wires on which data only flows. It carries only data. Address bus carries only address, whereas data bus carries only data in between processor and memory. But look at here, the data bus is bidirectional bus. So data can flow from processor to memory and memory to processor also. Both, it is a bidirectional bus because it needs to carry the data from memory to CPU and CPU to memory. Why bidirectional is required? Because suppose if I want to add data 5 plus 4, where the 5 and 4 is stored in the external memory, first I have to bring this 5 and 4 to the internal memory, internal registers, right? So the data from the external memory, the data 5 and 4 from external memory, it is through the data bus, it is brought to the internal registers and it is given to the ALU. After performing the addition operation 5 plus 4, the result 9 is to be stored again back to the external memory. Now the data is to be carried from CPU to the memory. So we need to bring the data from memory to CPU and CPU to memory. Hence that is the reason it has got two directional bus, okay, bidirectional bus. And one more, now another point is how many wires in the data bus. It depends on the processor, how many bit processor it is. If it is a 16-bit processor, there will be a 16-bit data lines, 16 wires in the data bus. If it is a 8-bit processor, 8 wires will be in the data bus, right? So suppose if it is a 8-bit processor will have a 8-bit ALU and set of 8-bit registers and 8 data lines in the data bus. Okay. So this is how we have to keep on adding the knowledge about the processor. And one more bus is a control bus. So here control bus shown in this orange color is again unidirectional. Control command, means it's a command sent always by the processor to the memory. Okay, what kind of control? Say for example, it may be a read command or it may be a write command. If you want to read from the memory, the control circuit in a processor will send a read command through the control bus, okay, and to the memory. Similarly, if you want to write the data into the memory, again write command will be sent by the control circuitry of the CPU to the memory through the control bus. So one more point to be highlighted here is address bus, data bus is actually a bus. Functionally it is a group of wires. That means you cannot access the bus as an individual wire. Whereas control bus is actually not a bus. It is not a group of wire, rather it is a group of single wires. That means control signals can be accessed individually, read command, write command, so many commands. Depends on the processor, complexity of the processor, right? So this is what the von Neumann machine of a architecture of the von Neumann machine. So most often any microprocessor will have these processor, all the blocks inside, and it will have a memory outside. Apart from that, it will have peripherals also, input output. So that we can say, for example, program is stored in a memory and data is also stored in a memory. Processor receives command and data from the memory through the address bus and data bus and control bus. Okay, but how can you store the instructions and data in the external memory? For that you need a device called input device, keyboard, right? Or similarly, to see the output you need output device. So they are also connected through the buses. address bus, data bus, and control bus, right? So these are all the, and again peripherals, right? So this is what the architecture of the von Neumann machine. So any microprocessor following this concept, it works, right? But I have explained only the architecture, structure of that machine. But how does it function? How this processor, memory, input output unit together function, that will be discussed in the next module in this series of video. Okay, thank you.